All right, so what I mean by the GCF of the GCF of the problem is that we are going to pull out a GCF that is not just a singular number, but an entire term. So both terms contain y minus 1. So the GCF of these two problems being subtracted by each other is y minus 1. So we're going to take out a factor of y minus 1, which will leave behind the coefficients 8 minus x. So here, the GCF is x plus 3. So that's going to leave behind x minus 2. My GCF is b plus c, which leaves behind x plus. Now there's nothing in front of that second quantity, but we know that like anything else, if we take something away, a placeholder must remain, and that placeholder is 1. So this is x plus 1. Similarly, on the other side, if you take out that GCF of r minus 1, that leaves behind m minus 1. So today our focus is on factor by grouping. So what we're going to do is take polynomials that are 4 terms, and we're going to group the first 2 terms and group the last 2 terms. So quadratics are typically 3 terms. However, we can have quadratic expressions that are 4 terms if they involve more than one variable. So we're going to use the idea of taking out a GCF, and this technique is called factor by grouping. It is also one of the steps we're going to use when we learn how to factor using any method. So what we're going to do is group the first 2 terms and the last 2 terms. Then we're going to factor out the GCF of those terms. And then the remaining binomial factor is going to also work as a GCF. So we're going to factor it out. And then that will leave me with my final answer in factored form. Sometimes we could encounter 4-term polynomials where the factor by grouping does not seem to work. So it's important to remember that addition and multiplication are commutative, and that there are times where we might need to change the order of the terms in order to get factor by grouping to work. So what I mean is you might have 2 terms in the middle and you need to flip-flop them so that when you regroup them, they have a common GCF. So we have 2x squared minus 6xy plus 5x minus 15y. So what we're going to do is just try from the start to group the first 2 and the last 2. When we group those 2 terms together, we're going to look for a common GCF of each group term separately. So the GCF of 2 and 6 is 2. The GCF of x squared and xy is x. So we're going to take a 2x away from each term, leaving behind x minus 3y. So that if I were to distribute that back in, I get the original. Similarly, over here, we're going to take the GCF of 5x and 15y. So we're going to take out a 5, and that leaves x minus 3y. What you should notice is that when I take out the GCF of each factored terms, what remains in the parentheses must be the same. So what remains in the parentheses must be the same. So in this case, what remains is x minus 3, x minus 3. So just like in the warm-up, we're going to take x minus 3 out as a GCF. And that leaves behind 2x plus 5. That is factor by grouping in a nutshell. So we have 8x to the fourth plus 6x minus 21 or 28x squared minus 21. So we could group them to start. Now, when you group them, if one of the terms is negative, a negative needs to go inside the grouping parentheses. So this is the case where like that plus a minus aspect kind of comes into play. But that negative needs to be grouped inside my parentheses. So the GCF of 8 and 6 is 2. X to the fourth and x is x. Leaving 4x cubed plus 3. Now, since both terms inside are negative, and my terms here are both positive, I'm going to factor out a negative with my GCF. So I'm going to take out a negative 7. Because taking out a negative 7 will leave me behind 2 positives. So that leaves behind 4x cubed plus 3. Now what's left behind matches for both. So I have 4x cubed plus 3 times 2x minus 7. Okay. We have 3x cubed minus 9x squared minus 9, or minus x rather, plus 3. So once again, our first thought is to group the first two terms and the last two terms. Again, where you're taking into account that that negative needs to go in my parentheses. So that's what I was hinting at before. It's kind of like that plus minus. So if you need to see the plus sign when you group them, you could write it in. You don't have to do this step unless you need it because you want to make sure you don't goof up. 3x cubed and 9x squared have a GCF of 3x squared. Negative x and 3 have a GCF of negative 1. Three is not a perfect square, so even though when we factor this out, I have 3x squared minus 1, because 3 is not a perfect square, I can't break that down as a difference of squares. If it was 4x squared minus 1, then you could factor it even further using one of the techniques from yesterday.
Does it matter if the x squared is like in the second set of parentheses?
Did you write 3x squared minus 1, x minus 3?
No, I wrote it the way you do, but I'm saying, like, is that okay if that's your final answer? It doesn't have to be, like, in order?
Correct. Okay. And then for example 4, same idea. You're going to group together the first two and the last two, you're going to watch your signs. In the first terms, you're going to take out a 4x squared. And in the last terms, you're going to take out a negative 9. So you have 4x squared minus 9 as our GCF of the first and second terms, leaving me with 4x squared minus 9 times x minus 2. Now this is where you are not done. 4x squared minus 9 is a difference of squares, which means we need to factor this one step further into x minus 2, 2x minus 3, 2x plus 3. Okay? Yes.
We were given that and we have to then say like multiply. Would you do like outside the FOIL, but you do like the
So if you had to like FOIL that back to the original,
yeah.
you would just do first outer inner last for like 2 sets of parentheses and then do it again. Yeah. Which we will eventually do stuff like that. Okay? So I'll pass out your homework. You'll have the remainder of class time to